So let's take a look at these questions here. So please stop me if you have any questions along the way. So a couple of things on this one here. Notice how first step was to make sure that we have it in the form that presents itself well to solve this by matrices. In other words, to bring all the constant values to the other side of the equation. And then once I do that, I can set up my my 3x4 matrix. And again, a couple of little things. You notice here that I always try to do everything using an addition, okay? Not a necessity, but definitely something that does help to eliminate sign errors, okay? It's always easier to add a number. And also when you're adding, whatever the operation, or whatever the sign is in front of the number becomes your operation. Okay, so here you're adding 5, subtracting 2, subtracting 7, adding 19. Okay, another thing you'll notice is, say when I get to a scenario like this here, I could have done this differently. I could have skipped this step of dividing row 3 by 3. Okay, to simplify it, I could have done I could have simply done, 3 times, -3 times row 2 plus 7 times row 3, multiplied both rows in order to be able to get my 0 here. Okay, instead, what I decided to do is I decided to simplify this row by dividing by 3, and then to exchange the rows. Now, this is where you have to be careful, because remember I said you don't want to kind of work with 2 rows, with a row twice in the same operation. But because this is a fairly easy one to do, just dividing by 3 and then switching them around, I allow myself to do that. But it just makes life easier since I already have a 1 in the second position to have that there. Okay, and then from there, again, I chose to go all the way to row reduced echelon form. Okay, is it okay to cancel out? So in the end, what you would like to do, and again, what you have to remember is that this is your setup for doing much larger matrices. And so when you're working with much larger matrices, you really do want to follow the getting that triangle of zeros. The other thing that's important here is that this idea of reducing matrices isn't just useful when it comes to solving systems of equations. Okay, you're going to use matrices in other contexts, and being able to put a matrix in row reduced echelon form is going to be something that tells you something about what you're working with. Okay, so it's not that it's incorrect, it's just not the pattern that we try to follow. We always try to get the triangle of zeros, on the bottom corner, and if you go to the reduced version, on the top right corner. Okay, so probably something you want to avoid. Any questions on number 1? Okay, so really the only trick here was making sure that you brought stuff to the other side of the equation so that you can set up your matrix correctly. Any questions on number 1? I can use elementary steps instead, right? What do you mean by elementary steps? Can you define what that means? Yes, okay, so Kieran, I've answered that question now, second time. I won't answer it the next time. Yes, on an evaluation, there's nothing that's going to say that you have to use matrices. Okay. So number 2, obviously what was different about number 2 is I didn't give you a system of equations. Okay, so here now your step number 1 is to set up a system of equations. This one here, fairly straightforward, okay, because they're telling you exactly what you're adding together. So step number 1 was to set up your system of equations, and then from there you can solve, and this would have been a typical type of problem you would have solved with 2 equations and 2 unknowns. How do you figure out what each piece of furniture is going to be equal to? So from this point here, it was actually a fairly straightforward solution, okay, other than the fact that you were dealing with these large numbers. Okay, but your actual coefficients, if you look at the 3 by 3 part of this matrix, was actually quite straightforward because the numbers were small. Again, here, notice in order to simplify my life, it would be nice to have that leading 1 in the third row. So that's why I take the time to divide it out by 2 so that I end up with the 1. It makes eliminating these other 2 positions easier, having a 1 than having to work with a 2. Okay. So again, I would say fairly straightforward. It was a fairly easy system of equations to write out. So are there any questions on this second one? I'll leave it up for a second in case you want to just check what you had done. No? Okay. So if there's no questions, let's move on to the next one. Okay. So this one here, a bit of an application question. Okay. So definitely, this is one of the reasons, you certainly, if you're studying any kind of engineering, you're definitely going to be taking a linear algebra course. And this is, I would say, a pretty simple application of matrices or solving systems of equations in an electricity context. Okay. So again, here, despite the fact that you do have to work with these, less than ideal numbers in your right-hand position, the actual 3x3 matrix, again, relatively straightforward. Okay. If you look at this step here, this is where, it really doesn't make sense. Having said that, when you're working with larger matrices, sometimes you just deal with the fact that you're working with fractions. But here I would say it made a lot more sense to not divide out this row to get a 1 in this position. A 1 in this position, and then use that to simplify the position below it to get your 0 there. It made more sense to just multiply both of the rows. So again, exactly what you would do back in the more traditional way of solving these systems of equations is I multiply both rows and then add them in order to achieve my 0. Okay. Now, once I get to this point here, again, I know that I want to solve for this z value, so I will have to be ending up with a non-integer. Okay. So there are times when it makes more sense to multiply 2 rows before adding them instead of turning one of them into a 1. Okay. And beyond that, the rest of it was, I would say, fairly straightforward. Okay. So if you have any questions, please let me know. Otherwise, I'll give you a minute to just take a look and check your steps. All right. So let me know if you have any questions. Okay. So if there's no questions, let's move on to this one here. So again, in this scenario here, you had to write out your system of equations. I would say 2 of the equations are quite straightforward. They give you a total of 200 flowers. So add up all the types of flowers together and you get the total of 200. The second one involves the total cost. So the cost of an individual flower times that number of flowers. And then you do that for each type of flowers, add them up, gives you your total. Okay, so again, very similar to the types of equations you would have been writing back in grade 10. And then this third one, the third one, maybe you had to do a little thinking. Here it says they ordered 40 less carnations than the other 2 combined. So I'm looking for the number of carnations. Here's my x, and it's 40 less than the other 2 combined. So the other 2 combined would be the sum of the other 2 minus 40 gives me my number of carnations. Okay, so you just have to be careful on how you're reading that sentence. It's very easy to kind of accidentally put the minus 40 here. So make sure you're reading the sentence very carefully so that you can interpret the correct equation. All right. The other thing you have to keep in mind is that this third equation, I wrote it based on translating this sentence, but it is not in the format that I want to set up my matrix. So here, this is why when I set up my matrix, okay, I notice that I bring the y to the other side, bring the z to the other side, leave the negative 40 on that side, and I get this equation here, okay? So in here, we see a lot of familiar, luckily, how funny that we always seem to almost always end up with the leading one. Again, this is your introduction to manipulating matrices. So we, tends to be simpler questions. We want you to just get used to this idea of the row operations. Okay, and I just go about my business. Again, here, once I get to something like this, it makes more sense to simplify the row before moving on. Okay. And then notice again, I did this old switcheroo. So I simplified this so I had a 1 in the second position, but a 1 in the second position is much more useful as the second row. So I also did the switch of rows. Okay, and then from there, relatively, there's nothing particularly interesting in any of this other than, you are working with some decimals, which is a little different from some of the others. Okay, so any questions on this one here? All right. Now, did anybody get to number 5? Was anybody taking the time to use matrices to solve this 4x4? Okay. So what I'll do is I'm not going to show it. The solution is online. Okay, so you can take the look. But there is a couple of things that I would like to say with respect to solving something like this. Okay, if we go back to say one of these simpler ones, you notice that sometimes I'll perform 2 operations in one step. Okay, so in particular, I know I'm going to be using this leading one up here to eliminate both the 1.5 in the second row and the 1 in the third row. Well, nothing stops you from performing 3 operations in one step. So presumably at some point, you're going to be using the leading one to eliminate the 1 here, the 2 there, the 3 there. You should be doing those all in one step, and if it was a 5 equation matrix, you would be doing 4 operations all in one step. Okay, so the only thing you want to avoid is, adding these 2 equations together and at the same time adding those 2 equations together. That's going to lead you to errors. Okay, but there's nothing that stops you from, operating with 1 and 2, 1 and 3, 1 and 4 all at the same time. Okay, so one way to really save yourself a lot of time is to, again, not just double up, but even triple up on some of those operations. Okay, so if you look at the numbers, it's about as straightforward a 4 equation matrix can get. It's a fairly easy one, but you will start to see how, there's a lot more writing, a lot more steps involved in the process. Okay, but the process itself is exactly the same. Okay, so this is why working with matrices is nice from a algebraic perspective, but of course, because it's so algorithmic, it's also nice for programming, solving systems of equations. Okay, and remember, you can always check a lot of, the Symbol Lab calculator doesn't just show you the final answer, but you can take a look at the individual steps. Okay, they might do them in slightly different orders, but you'll see that you'll be able to really check your answers fairly easily.